Hello guys, trust you're doing fantastic. In today's video, we're going to be talking about the 1's complement subtraction. In this scenario, we're going to be considering case 1, where we're going to subtract large number from a small number. So we're going to denote it as S minus L, which is small minus the large. Now, for you to carry out this operation, there are certain rules you need to follow. Now, rule number 1, you need to take the 1's complement from the subtrahend. Remember what subtrahend means. Subtrahend is actually the number that needs to be subtracted from another number. So that is the subtrahend. Now, the rule number 2 says add whatever you have gotten, which is the 1's complement, add it to the minuend. The minuend is nothing but the value from which we need to subtract another number from. So it means the number that is subtracting the other number. So that is the minuend. And then the rule number 3 says that if carry is not generated, the result is said to be negative. Alright? So if carry is not generated, the result is said to be negative, and it is in 1's complement form. Don't worry, you're going to see this in action very soon. And then once you have this situation, once you have this condition, what that means is that we need to take 1's complement again to get the actual result. So we're going to see this in action very soon. Alright, so let's take the first example. Alright, so the first example says, what is the 1's complement subtraction of 12 from 3? Now you need to understand the question before you can have an idea on how to properly arrange this value. 1's complement subtraction of 12 from 3 means that you need to subtract 12 from 3. So it means you need to write it this way: 3 minus 12, which means small minus large. This is what it means. Once you're able to decode this, the rest is very easy, very straightforward and easy. Alright, so let's go straight. Now, since we know how to represent this, the next thing we need to do, let's start following the rules. Now, step 1, we need to get the actual binary of 12, which is the subtrahend, before we can perform the 1's complement. Now, don't forget, this is the rule. So, for we to get the actual binary of 12, because this is binary subtraction, so it means whatever operation we're going to be doing, we have to convert the decimal value into its binary equivalent. So in this case, the equivalent of 12 in binary is 1100. Now, if you use this code, you understand what I just did. All right. Now, the minimum number required to represent 12 is 4 bits. So that is why we are using this. So the highest place value should be 3, 2 raised to the power 3. So that should be the highest. All right. So in this case, we represent 12 in binary. So once we've done that, the next thing we need to do is to take 1's complement of 12. 12 is nothing but the subtrahend. So once we take the 1's complement of 12, what it means that let's take the inverse of this binary value. That's what it means. The complement means inverse. So taking complement of this binary value means to take the inverse. So if we have to take the 1's complement of 12, it means taking the inverse of this value. So where you have 1, you have 0. Where you have 1, you have 0. Where you have 0, you have 1. Where you have 0, you have 1. So very easy. Now, don't forget this. How many numbers of bits do we have here? We have 4. So this is 4 bits. Now, this will help us. This will give us an idea in carrying out the subtraction operation. Now, step 3. Step 3 says, add the results you have gotten. So add the 1's complement result you have gotten to the minuend. Now, the minuend is nothing but 3. 3 is the minuend. Alright, so we're going to add whatever we've gotten to 3. This 3. So add it to it. So that's what we're going to do. So at this point, you need to understand something very crucial. Now, if you have to represent 3 in binary, now take note, the minimum number required to represent 3 in binary is 1 1. All right, it's 1 1. So if I close up these values, these two zeros, all right, so it means the minimum number required to represent 3 in binary is 1 1. Now if you check at this point, the highest place value is going to be 1, so it's going to be 2 raised to power 1, 2 raised to power 0, where you have, once you have 1 1, it means 2 and 1 is present. So if you sum it up together, you're going to get 3. So because 12 is 4 bits, so it means that whatever we're going to have, whatever number of bits we're going to have for 3 must match the numbers of bits of 12, or else you cannot perform subtraction operation. You cannot. That is the rule. So for we to able to match it up to have 4 bits, we need to carry out what we call zero padding. We need to pad to the left with zeros, with 2 zeros. Now we've added 2 zeros so that we can have 4 bits. So it means that these 2 zeros we have added, we have padded this with, has no significant changes. It doesn't change. In fact, let me not say significant changes. It does not change the value at all. It doesn't change it. So this is still the same value as 3, because these 2 zeros does not change anything. It doesn't change the values. Okay, it doesn't change it. It's still the same 3. So just for we to have the same bit number, we have to pad with zeros. Now take note, because you're going to find similar examples and questions in your exam. So take note of this. This is very important. Now, since we've been able to do that, so the next thing we need to do is we need to go ahead to carry out the subtraction operation. All right, since we need to add that, we've gotten the actual binary of 3 and also match it up to have 4 bits. Now addition, so 1's complement of 12, we know that is 0 0 1 1. All right, so this is what it means, this value. Take note. And then let's add it to the minute. The minute value, which is the binary, the actual binary is what? 0 0 1 1, which is this. All right, so now let's go. Let's plus it. 1 plus 1 is 0. Carry 1. So a carry is generated at this point. So we have carry 1. So we put the carry to this part. So we have 1 plus 1 plus 1. According to the addition rule, it's going to be 1 with a carry of 1. We'll have another carry. We'll bring the carry to this other part of the bit. We say 1 plus 0 is going to be 1. Now take note, we have 0 plus 0 is 0. Now in this last operation that we just performed, 0 plus 0, no carry is generated. So this is what you need to take note. No carry is generated after this last operation. So in this case, the rule 3 that says if carry is not generated, the result is said to be negative. So in this case, since no carry is generated after performing this last operation, since this last addition, no carry is generated, so the result is negative. In this case, it means this result is going to be negative. We're going to have minus 0 1 1 0. So in this case, the result is going to be minus 0 1 1 0. This is very easy because carry was not generated. Now in this case, since we have found ourselves in this situation where carry is not generated, we need to go further and perform the last operation, which the law says that if carry is not generated, we need to take 1's complement again in order to get the actual result. All right, so let me take you back to the 4th rule that says that. So the 4th rule says that. So it says, the 4th rule says that take 1 complement again to get the actual result. Now let me make that very visible. It says that if carry, now if carry is not generated, the result is said to be negative, and it is in first or 1's complement form. So it says you need to, it's a must. So we need to take 1's complement again to get the actual result. Like I said, we're going to see this in action. So let's take the 1's complement again. All right, so let's go straight up to the final part. Okay, so step 4 says take 1's complement again. Now we're taking the 1's complement of this. So let's take the complement of this. Complement means taking the inverse of this result we have gotten in order for we to get the actual result. So the complement of this is going to be where you have 0, you're going to have 1. Where you have 1, you're going to have 0. Where you have 1, you're going to have 0. And when you have 0, which is the final bit, you're going to have 1. So in this case, if we convert this to decimal, we're going to have -9. All right, so this is how simple this is. Simple to solve 1's complement subtraction. Very easy. All right, at this point, I'm going to encourage you to pay attention to the subsequent videos in this channel because I'm going to be treating more and more examples. All right then, enjoy this video. Bye.